Cześć, everyone. It is fantastic to be here. So I'm really happy to see you all. Let me start with a story of mine. It was 2009, as far as I remember. We had been using a centralized version control system for a long time. It was SVN. We've been using it since 2004, and we were having troubles. The network in the company was poor, and whenever you need to share your commit with your friend, you have to wait for minutes, and we were really not happy. And on those days, we were thinking about switching to another version control system, and our technical leaders suggested to move to Git. At 2009, I was not aware of Git. I searched at Google and noticed that it was written by Linus Torvalds. Hey, that's interesting. If Linus, everyone has respect to Linus, and if Linus Torvalds as a name is on something, you can expect some good, cool stuff, right? And on the other hand, when I searched the articles and tutorials, I was confused. I mean, it seemed to be hard to adapt because I couldn't understand the snapshot mechanism of a distributed version control system, and many things were unclear. But anyway, we moved to Git. And in few days, we moved hundreds of repositories and 250 million lines of code to Git. Then we start to have troubles because we didn't know how to use Git well. And a few weeks later, one of my friends, just sitting in front of me, shouted and screamed, and he said, he lost 3 days of work. Since we were the guys who, people think that we know Git well at that time, we tried to help him, but couldn't find a solution. And at the end, he rewrote the whole 3 days of work again. And that was a breaking point for me. And I thought I should have learned better, Git better. And I pushed myself to learn it, to practice it again and again. And I started to notice patterns. And it's a kind of anti-patterns, like tons of errors, tons of misbehaviors while using Git. And you may see patterns in everywhere, and you may see anti-patterns in everywhere. So in this session, I will describe the anti-patterns that I found in my career. Okay? Let me introduce myself in a very briefly. My name is Lemi. I'm from Istanbul. I've been working as agile software craftsman at EasyCo. EasyCo is a payment service provider. You can call it as a Stripe of Turkey. And I've been developing software since 2001. I'm a community guy, and I really loved working at communities, and I founded Software Craftsmanship Turkey with my friends, and we organized several conferences since 2006. And I really love Git at the end. Now, I really love Git because not because it's written by Linus Torvalds. And that might be the reason, but in the end, Git has a fantastic internals and internal mechanism, and that fascinates me a lot. Therefore, I really love using Git. And but one point is important. The more you learn Git, you become more comfortable while using it. Like in Scrum, Scrum is easy to learn but hard to master, right? And Git resembles Scrum. So you have to practice it. You have to learn how Git works in order to use it properly. Now we can start covering anti-patterns one by one. So I know that many of us just commit and push regularly. You commit and you push. You commit and you push. If you do that, it means you are using it as Dropbox. Unfortunately, Dropbox is a better tool, more efficient tool in order to get backups. And if you're using in that way, please stop using it. Use Dropbox instead. Instead is a better tool for that, okay? And in order to not to use Git as Dropbox, we have to learn Git and the Git internals, how Git works, how Git behaves when you run a command. We have to learn it briefly. So I will describe you how Git behaves in few slides, okay? So Git has two mechanisms, and with those mechanisms, Git governs everything. So Git governs your files and folders and branches and all references. Git keeps your files and folders as objects. What it means is that they are kept in the file system as compressed objects, compressed files, and they are stored in the .git folder. .git folder is a Git repository. So if you see a .git folder, you can imagine that the code there, the things that they are versioned. And if you remove the .git repository, it means you lose all the versions, but you have still the source code there. And also Git handles all files and folders in an object graph. It's a directed acyclic graph, which means there are no cycles and no bidirections, and it puts all objects there and handles the versions and in that graph. Okay. I will show you briefly. So you want to keep the versions of this source code. Okay. So you have packages and you have a source code. You have a file there, and you want to keep the versions. So whenever you call git init, so there is a .git repository is created and the cache is created. You can call the cache as the staging area, the index file inside the .git folder, and they are created but they are empty. So you can also want to create a repository on the remote side in the upstream. What you need to do is git init --bear. What it does is it creates a Git repository without any source code. You cannot see a .git folder in the remote. However, you can see all the things inside of the .git repository on the remote server, okay? But it's empty too. I mean, the default files. And you want to keep the version. So first you need to do git add. Git add simply adds your files to Git. It's as stated. So when you call git add, Git checks the files and folders and creates objects and compresses them via zlib algorithm and puts to the object database. It's an objects folder, okay, objects directory, and also it creates entries in the index file. So and Git puts all your files and folders in a graph. So here you can see the graph of that sample. So it's so simple. I mean, it's like what we program in computer science department in universities. So terminals are files and nodes are folders. Okay, and whenever you create a commit, whenever you commit your changes, it's lightning fast because it just creates just one file. Nothing extra. It creates just one file and it puts to your local on your objects directory. And therefore, it is lightning fast when you commit, but it's local. And here you can see that your commit creates another node and a pointer for branch, your master branch, and the head pointer. So it creates references now. And your graph will grow from now on. And whenever you create a new commit, you can see that your graph enhances with the new objects and new nodes and new terminals. Here you can see your new commit shows the folder and file structure. And some of the files are shared, some of the files are recreated because they're changed. The file on the bottom is just changed. Therefore, whenever you commit, the only change for that file, you create a new object and you share already existing objects for the other files. And when you create a new commit, you can see your graph enlarged, enlarged, and enlarged. And the whole stuff, you can see that the commit, you can see those commit nodes. Those are the ones that we see in the commit graph. But we cannot see those files and folders in our commit graph. They are hidden. And now let's push them to the remote. When you push them to the server, you simply upload your files and folders. Nothing extra, nothing more. Just an upload. It's like an rsync command. And that is the simplicity in the mechanism that Git governs the objects is so fascinating. And you imagine that your colleagues, they are just pushed to the server, and you want to get all their commits to your local. And what you need to do is first you need to run the fetch command. Git fetch simply downloads all the files and folders or the objects. So some of the tags with messages, they are also objects, and you download them to your local. But here you can see that your local files, your source code has not been impacted. And then you should do is a merge activity. When you run git merge fetch hat, it means you should get all those changed objects and impact your source code. Git contains many hidden head pointers, like cherry pick hat, oric hat, merge hat. There are like 7 or 8 different hats. You cannot see them, but they are there. They are there because you are traversing your Git graph very regularly, and like when you fall into a conflict, you have to roll back, abort it, or continue. So with those all head pointers, Git knows where the process has stopped. Then hopefully there is a shortcut command, git pull. Git pull simply runs git fetch and git merge. Okay. And Let's update the last commit. If you really would like to update the last commit, what you need to do is the two commands are very proper for that. So the one is git commit dash dash amend, and the other one is soft reset. They have a very slight difference, but in general they are very close to each other. When you do a soft reset, the graph, the pointer, the branch pointer and the attached head pointer just moves backwards to the previous commit, and your last commit becomes inaccessible. And for your current branch, the entry in the cache in the staging area disappears. Okay. And here, for example, when you do that, your pointer just moves backwards. That's all. That's all. That's perfect. And let's squash the last n commits. If you really would like to squash n commits, then what you need to do is git reset or git reset dash dash mixed. The mixed reset simply get all your source code as if they have you haven't been committed yet. And in your source code, you can see all your last n changes as uncommitted and unstaged. So in that sense, you can see that you can imagine that the pointer moves backwards again, and also the entries in your branch and in your head, they are just removed in the staging area. And you would like to get rid of all commits for a reason, for n commits, of course. Then what you need to do is the hard reset. You may use hard reset from time to time. It's one of the most dangerous commands because you may lose your uncommitted code if you forget. Okay, and your changes are gone. Okay, let's move to another anti-pattern. So, are you brave enough to jump to a commit whenever you like? Version control systems are time machines. So, since it's a time machine, you should be able to go back to any commit at any time. But it's risky, isn't it? I mean, if you go back to a random commit, you may encounter a fully messed up source code, right? The test might fail, the application might not work, so it's risky. However, that is an anti-pattern. It should not be like that. So due to that anti-pattern, we always put tons of tags, tons of branches, and we do not delete them. Because if somehow we would like to go back, we should find that tag or that branch. So here, it's a real screenshot, and there are tons of commits like this. Their commit messages are the same. So is the last commit means the feature is completed? It depends, I don't know. No one can know. So they're all there, they're half done, not done, and at the end it's done, or is it really done? So we have to understand it. So we love branches, right? Git is very, very famous about branching, and very powerful. And we really love creating branches because it's so easy. When you create a branch, you only create 20 bytes. That's all, 20 bytes of pointer. However, when we create a branch and check out into it, we live in it. We live in it for a long time. Creating a branch and moving into it is like leaving home for a trip. If you come back in few days, you may see your houses there, the people, they are waiting there, and you might not see any differences in the city. However, if you leave home and come back 30 years later, even it is possible that you might not found your house. So so we have to keep our branches short. Now, for example, this is a real scenario. It's a highway pattern. There are around 40 branches. They are waiting to be merged. They are there. They are waiting to be merged. But how? How can people merge after 6 months? It is written and it's been waiting for 6 months, and no one can merge it back easily. Okay. And there's a cure. I mean, I will propose some cures, but few slides later, okay? And we really would like to, we have to validate our commits before merging. But is it really possible? I mean, we are running continuous integration servers. It runs your unit test after every commit. You create code reviews via tools, or you are doing pair programming, but at the end, most of the time, after your merge, you do the validation. Do you remember that graph from a flow, Git flow, right? I've been using Git flow for a long time. I mean, for years, and it seems after spending years with it, now I see that tons of branches, and you have to check and validate your commits after you merge, and that's too late. You have to get feedback immediately. You have to get feedback from your colleagues before your branch is really merged. Okay. And I have some clues about it, so a few slides later. And I've been consulting companies for a long time, and I've seen lots of different Git branching mechanisms. For every release, they create a release branch, or even weeks before the release, they create a release branch, and these branches are waiting for commits. And they use cherry pick for everything. Do you use cherry pick? People love it. Cherry pick is the ultimate command for some of the guys, like architects, like technical leads. They are there to do cherry pick because no one can merge tons of different commits in one day. I mean, you have a release today, and your manager says that I don't want that feature, I want those features, but not that one. But you already merged. What you need to do is you cherry pick one by one each commit to your current release branch. And that's an anti-pattern. Okay? I will come to that point again. Okay, so commit graphs. Commit graphs should be well understood, should be readable, because they are there for developers. Developers hate documentation, right? We hate it. However, we document a lot, like writing tests, like commit messages, like we are creating commit graphs because we create it, and someone, your colleague, the guy sitting next to you, needs to read it. If that is the case, we are creating documentation a lot, and commit graph is a documentation, and it should be readable. But how can we read those things? It's a mountain pattern in the commit graph. Highway pattern, ladder pattern, and a mountain pattern. So how can we understand something happens there? What happens there? So it should be readable and well understood. Okay, what is the cure? So there's no single cure, of course. I mean, Git is so powerful that everyone might have different ideas, and your ideas most probably might be better than mine. Therefore, the things that I will describe, they work for me, but they might not work for you and in your conditions. So I should state that beforehand, okay? Thank you. And so the philosophy is commit early, commit often, perfect later, and publish once. It is written so simple, but it's not so simple while practicing it. So let's start by keeping your branches short-living. What you need to do is you need to separate your feature into tasks, like in Scrum, right? You have features. If your feature is big, you have to split it into short sprints, and that's the point. You have to separate your feature into short testable parts, and we will commit those things. Okay. Now you have to commit early, commit often. You do not need to check if the tests are passing. That's okay for now. And even it might not compile, that's okay. You commit early and often because you need versions. Git is a time machine. You have to go back to any commit for any reason. Now you're working on a feature and Git commit early and commit often, but do not push it. Push is an important comment, and according to me, people can pay for push comment. I mean, you can pay €1 for each push, so you have to stay away from push for a few times. I mean, and do not push. Okay. Wait for it. What to wait? So your colleagues, they are pushing, right? They are pushing before you. So you have to get their commits to your local. What you need to do is please do it with a pull rebase. Without using pull rebase, I mean, with using a bare pull command, you might have seen some anomalies in your commit graph. I will have a different section for it. And git pull -- rebase origin master simply gets all commits from to origins master to your locals master, and it makes a rebase, and it moves your commits on top of it. Okay. And do not forget to push if you already pushed the remove, because you are changing the commit history. Okay. If you commit already, you have to force push to the removed. And now it's time to synchronize your source branch, which you can use git fetch origin master :master. That's the most used comment in my team in these days. Okay, now it's time to make it single. If your branch contains only one feature, you can squash it into one commit. What you can do is you can use reset. That's fine. You can reset to n commits backwards and make it create a new commit. Or if you really would like to prepare m commits from n commits, then you can use interactive rebase. Interactive rebase is a wonderful. You feel like, I mean, you are configuring your Git to push a satellite to Mars, and like it's incredible. Now you squashed it, and you have to, of course, create a new command afterwards. And what you need to do is you have to, I mean, you should push it to production. Therefore, you should use feature flags or feature toggles. Like Sam mentions in the previous session, it is important. And you disable, it is important to overcome all these anti-patterns. And I can summarize the things that I described till now in one slide. Few extra points are very important, like you have to deliver frequently. What I mean frequently is like few times a day. At EasyGo, we are deploying to production like 4 days, once in a 4 day. However, we feel that it's not good, and we have to make it more frequent, like once a day, and our next aim is few times a day. So you have to build your continuous delivery procedure on your system, okay? And for code reviews, you can use GitHub Flow. GitHub Flow is a cool, is a really working mechanism for your branching model. Okay, and do not forget to delete branches, please. Please, branches are there for keeping your unfinished work. But whenever you finish your work and merge back to your source branch, you can delete it. You should handle which commit belongs to which feature from your commit message, not with your branch name. Now, there are some other cures. What are they? I can mention few more cures with you in a very first phase. So, developers really love using user interfaces, right? Especially while using Git. I mean, we click on the push button. What it does is it runs Git at point, which gets every change in your local and commit to it and push it to your upstream. However, that means you are using your Git like Dropbox. So avoid using user interfaces or applications. There are some exceptions, of course, like when you need to resolve a conflict or see a diff, you may, or see a commit graph, even though I use terminals for seeing the commit graph. You can use user interfaces, but avoid it, okay? You have to know Git well. Therefore, you should use Git from command prompt terminal. Sorry. And no one wants to lose uncommitted codes. Yes, right? Therefore, you should use git stash or git reset with dash merge, or you can directly commit it. What is git reset dash merge? It tries to do, it's a hard reset, by the way. However, if you have an uncommitted code, Git checks if the things that I resetted has a conflict with the things that are newly written in our source code, and if there's a conflict, it stops. I mean, it prevents you from deleting uncommitted code. If you really would like to do hard reset, you can use merge reset. And even though you agree that, yeah, we should keep our branches short, you might have some long-living branches. Then what you need to do, you can squash it. You should squash it. Yeah, you can say that why I'm squashing. I mean, it's a long-living branch. There are 30 commits there. So why should I squash it? And 99.99% of your time, you won't need to go back to any intermediary commit there. So they are there, but no one needs it. If you imagine you squash it, most probably nothing will change in your life. So therefore, in our team, we are squashing all commits in a feature branch. Or we can create more than one commit, of course, after squashing. Also, stop adding all your changes to your next commit, because I'm sure that your changes might contain a bug fix there, a part of the feature and the part of a refactoring. So you do a git at that dot, and you get all the changes and push in one commit. Do not do that. Hopefully, JetBrains tools has a feature like local change set. With that local change set, before even creating a commit, you can separate your changes into logical sections, logical groups. That is perfect. You can use it. We are using very heavily. And also, you can use a partial add. Partial add seems a little bit weird. However, if you get used to it, it's very powerful. And with that comment, in that example, we have at README file, we have two different changes, but we would like to add only the first one, not the second one. What you need to do is you first add the first one and not the second one to your commit. So at the end, whenever you prepare your commit, whenever you do a check status, you can see that your changes are added and modified at the same time in the same file. Okay. And commit messages are read by your colleagues, and they are read to be understood. Therefore, they should be written wisely. Yeah, that's boring. It's boring to write commit messages, but we should spend time for writing commit messages. What we can do is we can have some guidance. What it means, hopefully Git has a template mechanism for Git commit messages. So you can use the git dash commit dash template txt file, but whatever, at the end you can use it. For example, in that sample, whenever you really need to add something, that template is opened and it directs you and it shows you some guidance points. You should remember those points, okay? And it really helps to improve the quality of your commit message. Okay, now let's go back to the initial story. So what should have happened, or what happened to my colleague? Why he lost his 3 days work? Because I've been thinking it for a long time. Why he lost his 3 days of work? And I have some ideas. No one knows, in fact, the real reason. However, I have some ideas. One idea is, my friend, unfortunately, he checked out to a commit, a tag. He might believe that it's a branch, but it's a tag. And he fell into detached head state. Detached head state means that your head pointer is not showing a branch pointer. So head pointer is now alone. It's alone in the ocean. So that's dangerous, right? Or another idea, my friends might try to run a git reset command just for trying. I don't know why, but he might try and he might get a conflict. Whenever reset stops due to a conflict, you stopped in a detached head state. You have to abort it, or you have to fix that conflict and continue. So you have to handle that conflict before moving on. Therefore, most probably, that might happen. So, but my friend couldn't notice the detached state and worked for 3 days, my poor friend. Then, due to a reason, most probably due to a bug fix, he checked out to master branch. Oops. His 3 days of work disappeared. They are there. You cannot lose your commits in Git very easily, by the way. But they might disappear because remember the graph theory? Git cannot enter that graph from those green nodes. Git cannot find those nodes while traversing the graph. They are there, but Git cannot find it. Now, we know that that might happen, but we know that there's a clue, and there's a cure for it. So what we need to do is we need to run git ref log. Git ref log is a log keeping your movements of your head pointer, and it is specific to you. So your friend might have a different ref log, different output when he runs ref log, and you can, from the ref log, you can start to check your entries one by one. You might use git show command. Git show commit ID simply shows the internals of your Git. The data, shows the data for your commit, and you can find your last commit there, and you can create a branch for showing Git how to enter the branch, how to enter the graph. Okay. Now Git can traverse the graph and find those missing nodes. Okay. And if you think that you lose something while using Git, no worries, because it's really hard to lose code. If you may lose your uncommitted code if you do a hard reset. Other than that, it's really, really hard to do. So feel relaxed and just use git ref log. Those are the things that I can describe. I have additional 15 anti-patterns, but it takes time. Therefore, I hope we can meet on a meetup or on an event in the future, and we can cover all the other 15 meetups. Thanks a lot. I believe in the power of Kaizen. I'm a full-time apprentice. Therefore, your feedback is very valuable for me. Please send your feedback via the app or via social media. Thank you very much for coming. Thank you.